Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, today we're going to learn about empirical formula. And why would we do it? Well, in a previous video, we learned how to do percent composition by mass of a compound. Today, we're going to do the same thing, going backwards. So you're going to say, okay, I'm going to give you a percent composition, and I'm going to ask you what's the formula of a compound. It's pretty simple enough, but we will not be able to get the whole formula. We will not be able to get the formula of a compound. Why not? Well, there is a little problem. The best we will be able to do is to get the empirical formula of a compound. So what is it? Well, let's look at my screen. So empirical formula of a compound is the simplest whole number ratio of atoms present in a compound. If I give you a formula of a compound, let's say we're going to use nitrogen dioxide. Nitrogen dioxide is a brown, poisonous gas, not something you want to be around. And we also will look at this compound, dinitrogen tetraoxide. If we do percent composition by mass, which we did in a previous video, and we very fast assume 1 mole, I write it in red because it's very important. We're also going to assume 1 mole for this. So I'm going to actually give you a quick review of percent composition by mass. So our total mass is then, well, nitrogen is 14 plus 2 times 16, oxygen is 16. Our total mass is 46 grams. So percent composition of nitrogen will be 14 times 1 over 46 times 100, and that will be 30.4%. And if we do percent composition of oxygen, well, 2 times 16 divided by 46. So we have 32 divided by 46 times 100, and that will give us 69.6%. Just to make sure, let's make sure they add up to 100, and 30 plus 70 is 100, so that's good. Let's do quickly the same thing for dinitrogen tetraoxide, and we're going to see that there's total mass of that compound, if we assume 1 mole, will be 92 grams. And we're going to do percent composition of nitrogen. Well, we're going to do now 28 divided by 92 times 100. And when we do that, we're going to see it's going to be 30.4%. And if we're going to do percent oxygen, percent composition by mass, now we're going to do 64 divided by 92 times 100, going to see that it's 69.6%. Again, that adds up to 100. So you can see that there's 2 different compounds, 2 totally different compounds that have the same percent composition by mass. So if I give you percent composition by mass, the best you will be able to do is to give me the formula that has the simplest whole number ratio of atoms present, and that is the empirical formula. This is why. So let's start and do the problems. here is, calculate the empirical formula for a compound that contains 43.6% phosphorus and 56.4% oxygen. This is percent composition by mass. Well, what do we want to get? We want to find the formula. So we want to have P, we will have some atoms, and OY. We have P, X, and OY. We need to find X and Y. Well, what are X and Y? Well, they are our mole to mole ratios. If I have 1 mole of this compound, how many moles of phosphorus do I have? How many moles of oxygen do I have? Well, when I did percent composition by mass, I assumed 1 mole. It made my life very, very easy. Now I have to assume something else. So if I'm giving percent composition by mass, what can I assume to make it easy? Well, mass. What mass can I assume? Well, my percentages will add up to 100. So if I assume 100 grams, I am set. If I assume 100 grams, what happens then? Well, what's 43.6% of 100 grams? Wait, that means I have 43.6 grams of phosphorus. And what's 56.4% of 100 grams? Well, that's 56.4 grams of oxygen. I have my masses. But remember, we want to find X and Y. They are mole to mole ratios. Now I have mass. What can I do? First step, so let's change things to moles. So phosphorus times, well, there's 1 mole of phosphorus. And what's the molar mass of phosphorus? Let's look at our periodic table. I'm going to say it is 31.0 grams of phosphorus. And oxygen, I'm going to say I have 1 mole of oxygen, and 1 mole of oxygen is 16.0 grams of oxygen. So let's do some math. So 43.6 divided by 31. Let's keep our sig figs. Remember to keep your sig figs, right? At least 3 right here. So I'm going to have, I have 1.41 moles of phosphorus. Okay, same thing for oxygen. Let's figure out how many moles of oxygen I have. I'm going to have 3.53 moles of oxygen. Okay, great. I have my mole to mole ratios now. So I can say, well, here it is. P 1.41 and O 3.53. And some of you are saying, no, I never saw a chemical formula like that. And you are right. You see formulas in whole number ratios. That's what empirical formula is, whole number ratios. These are not whole number ratios. So you say, okay, let's just multiply it by 100. That will give me a whole number ratio. Okay, well, what about P 141 and O 353? Did you ever see such a formula? That looks really weird. That's probably not what we're supposed to do. This looks awful. So we're going to erase that. This is not what we want to do. We want to get the simplest whole number ratio. These are ratios. If I do something to one and something to the other, the ratios will still be the same. So what if I divide by the smallest number? That will give me one number to be 1. Let's do that. Let's divide. I'm doing a color change here on a purpose. If I divide by 1.41 and I divide this by 1.41, I'm going to get, well, now I'm going to have 1 mole of phosphorus. And if I divide this, divided by 1.41, I'm going to get 2.5 moles of oxygen. That's great. I'm getting closer. I can say, hey, I have P1 and O 2.5. However, that's still not the empirical formula. Remember, we want to do the smallest whole number ratio. So what should we do? Again, what can I do to these ratios to make them still the same in whole numbers? I think going to multiply by 2. If I multiply by 2, this will be 2 and this will be 5. Now we're getting somewhere. Let's do this. So the formula, empirical formula of this compound is P2O5. That's great. That's how you do empirical formula. So let's review quickly what we did. We did some steps here, our summary. The first step we did, sometimes you'll be given masses. If you are already given masses, that's great. You can skip the first step. But if you are given percent composition by mass, you're going to assume 100 grams. Just like we did. Made your life very easy. Once we assumed 100 grams, we got masses of the compounds. Then we're going to use molar mass to get how many moles of each compound we have. So take the grams, turn it into moles. Use the molar mass on a periodic table. Number 3, you're going to divide by the smallest number. By the smallest number. So then one of your elements will be 1. And then step 4, sometimes it might not be needed, you will multiply. You will multiply to get a whole number. So you ask, you multiply by what? Think about the decimal you got. Change it to a fraction. When I got 2.5, 0.5 is like 1/2. And I have 2 in a denominator. So if I multiply by 2, I can get rid of a 2 in a denominator. So if you're going to get something, let's say 2.33, multiply by 3. If you're going to get something with a decimal 0.25, well, 0.25 is 1/4, multiply by 4. You will usually be multiplying by 2, 3, 4, 5. These are the numbers, 2, 3, 4, 5. Really, that's it. Okay, let's keep going and do, how do you go from empirical formula to actually the molecular formula of a compound? So let's solve another problem. So here is, we're going to review our empirical formula and do one more step. So nicotine, let's use nicotine. A stimulant found in tobacco has a mass percent composition, well, carbon 74.03%, hydrogen 8.70%, and nitrogen 17.27%. The molecular mass of nicotine is 162.26 grams per mole. Find the molecular formula. So it's asking us the formula of nicotine. Before we can get molecular formula, we first have to find the empirical formula. So let's do that. What was the first step? Do you remember? Well, we have percent composition by mass. We're going to assume 100 grams. And that means I have 74.03 grams of carbon. I have 8.70 grams of hydrogen, and I have 17.27 grams of nitrogen. Here we go. Step 2. Let's change it to moles. Our formula, remember, will be CX HY NZ, and our X, Y, and Z are our mole to mole to mole ratios. That's what we want to find. So let's keep going. So carbon, there is 1 mole of carbon per 12.01 grams. I am using molar masses with more decimal points because of sig figs. Here's significant figures. So 1 mole of hydrogen is 1.01 grams of hydrogen. So this is at least 3 sig figs. And nitrogen, I'm going to say 1 mole of nitrogen is 14.01 grams of nitrogen. So let's get our calculators and quickly change things to moles. Divided by 12.01. So we're going to have, we have 6.16, and actually one more sig fig, 4 moles of carbon. We're going to have here 8.61 moles of hydrogen, and we're going to have 1.233 moles of nitrogen. All right, so we have our mole to mole ratios, but they are not in whole numbers. So step 2 is we are going to divide by the smallest number. Let's do that. And the smallest number is 1.233. So we're dividing everything by 1.233. Divide this by 1.233. Divide this one by 1.233. Well, this becomes nitrogen will be easy, 1 mole. 1 mole of nitrogen. Let's figure out what we will have. Here, 6.164 divided by 1.233. We're going to have, well, you know what's 4.999? I'm going to say I'm going to have 5.0 moles. And let's do this one, 8.61 divided by 1.233. And I'm going to have 6.98. So I'm going, it's pretty nice to say it's 7.0 moles. And in this case, I have nice numbers. I do not need to multiply by anything. So my empirical formula of nicotine is C5H7N1. Here is my empirical formula. But we want to find the molecular formula. So let's rewrite the C5H7. We have C5H7 and N1. And my molecular molar mass was 162.26 grams per mole. And empirical formula, it's you can multiply by a whole number and get molecular formula. So we're going to do our molecular formula. And I'm going to say molar mass divided by empirical formula molar mass. Empirical formula they're going to give you a nice whole number ratio. It better be a nice whole number ratio. If it's not a nice whole number ratio, you messed up somewhere. So maybe your molar mass is wrong. Maybe your finger slipped when you were doing calculations on the calculator. Go back and check. You should have a nice whole number. So let's do this here. We have 162.26, and we're going to quickly figure out our empirical formula molar mass. Let's do this. So carbon is 12, so 5 times 12 plus 7 times 1 plus nitrogen is 14. Oh, 81. If we divide this, we get a nice number 2. Now, that's my ratio. I'm not done yet. I'm going to take this 2, and I'm going to multiply all of my subscripts. So now, the formula for nicotine is C10H14N2. And that's it. I hope you enjoyed it. Hope you enjoyed the video and you learned how to find first what empirical formula is and how to find an empirical formula and then molecular formula of a compound. Thank you.